Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is Libretro Impl Part 10, if I can read my own slides. Last week we took a little break from this Libretro stuff and tried to isolate some of the timer issues by porting re-implementing one of the sample playback routines from Galactic Pinball, I believe is the one we did. Now, before I jump back into the actual stuff we're doing today, I actually want to go over that a little bit because I did a little bit more testing last Friday, and I didn't do terribly much, but what I did is I took that sample playback routine and I just changed some of the parameters. So like the reload low value, for example. I also tested which register values were used to disable and re-enable the timer. I didn't get through that many different combinations just because it was tedious and it was kind of boring. So what I would like to do at some point is hook up the live ROM reload stuff that I made last year and at least add enough interrupt support so that we'd be able to reload the sample playback code. But anyway, so I would do that, and then I would say what I would expect the period to be, what it was in Rush Tool Boy, and then I got kind of rough numbers about what I observed on the hardware. And the way I did that, again, is because it's a sample, I can kind of hear if I play it simultaneously on the hardware and in the emulator, I can kind of hear if it's too fast or slow. And then I have this other program that dumps the sample into a WAV file, and I can adjust the sample rate on there until it sounds like it's about the same. And then once that works, I can figure out what the period of the timer is because that's the length of one of the samples. So generally, some of this aligns, but most of it doesn't at all. So it looks like we're at least half of a timer period early on a lot of these. But when I started doing these longer intervals, I noticed that half suddenly became like a quarter or less, and it seemed a little strange. So I'm not really sure what the pattern here is, and I need to look into that further, but I've just done that and added some notes. So if the pattern were super obvious, then my plan was to just try to implement whatever would satisfy that pattern. But because I'm starting to see, as I increase these timer values, this overhead seems to get a little less significant. I'm not really sure what's going on there. I'm really not sure. So I think the next step with this part of the project is going to be to capture more of these. And maybe I'll do that on the stream one of these days, but we'll see. In any case, I think this is fairly interesting. One of the things that I noticed basically right off the bat is that some of these are just completely wrong in Rush Tool Boy. And it looks like these are usually too slow in Rush Tool Boy. I think a lot of this is because I believe that I don't raise timer interrupts on a 1 to 0 transition when the counter reaches 0. I think I'm actually doing it when it wraps around from 0 to the reload value. I think fixing that alone would at least make these run a little too fast rather than a little too slow, but I actually think that's closer to what's actually happening. And the rest of the overhead we're seeing is probably due to the CPU spending time between reloading the timer or not. I'm not entirely sure about that, and there's more tests I want to do. I also want to extend some of these and say okay, if we read the timer value at different points in this routine, what do we actually see? And there's probably going to be some variance in that, and I would like to see. Yeah, it would just be interesting to see if that gives us any additional information about what's going on here, especially because it seems that certain of these values that we use to disable the timer will reset the internal timer counter, and some won't. And it seems to be ones that I didn't expect that make it work. So couple things that are interesting there. But yeah, so this, I think I just need to do more data collection on this, but we're not going to do that today. Today I want to chug through some more Libretro stuff. Last time we looked at that, which was 2 weeks ago, we were just continuing on serialization. I believe last week I merged a pull request from Dr. E-Man, I think he's called on GitHub, and that's MoveAway00 in the chat. And let me pull this up here because I wanted to test some of this. Admittedly, I ended up just merging it without testing it, which I think is fine. I mean, I looked at the code, of course. By the way, hi to guys in the chat, Zokwar, Mad Moose, and Repnop. Bit of a smaller crowd today, but I do not mind. Anyway, the main thing that he did here is he looked into the serialization that we were doing and he made it a lot faster. And in particular, he writes, "Hey Gizmo, how's it going?" He writes, "It's pretty cool to turn on rewind and not bring things to a grinding halt." So I would actually really like to just test that, because I've never even played with this. I don't know how loud the system audio is right now. But this is lovely music, by the way. Anyway, I actually don't even know how to turn this on, so we'll figure this out together. Save state options. I'm guessing it's not that. In fact, it's probably in here. Also, I really should be testing with later RetroArch, shouldn't I? In fact, I'm going to do that while we're doing this. Hey, Two Curbs. I don't think I've downloaded RetroArch in about a year. I'm guessing there's some updates since then. Do the 64-bit download. And I'll just set that off for now. Hey, Michael C. Yeah, congrats on being on time today. Let's see. Throttling. Recording? No. I forgot I have these other screenshots. It's so cool to see this stuff actually starting to work, you know? Just by implementing various parts of the core. I'm actually wondering if it's saving. If this gives us anything interesting. I mean, this stuff is nice, but not what we're looking for. Yeah, I'm guessing this is recording output from the emulator, which is not what we want. Can probably actually Google this, but I kind of want to find it here. No, I'm giving up. Hey, Drew. How do you rewind in RetroArch from 2017? That's probably relevant. Default hotkeys are on the keyboard. While playing hit it, if it doesn't do anything, go to settings, frame throttle rewind. Here it is, yeah. Slow motion ratio. Initializing rewind buffer with size 20 megs. Oh, you can do frame granularity. That's rad. Let's do that at 1. I want to see this. Oh, this got slow. Is it going to catch up? Oh, no. Oh, that was painful. Is that because it was just slow or what? Seems like it. Yeesh. Yeah, this is using about a full core CPU. And then some. Woof. We are going to sit through this because I want to see this work. Oh, yeah, of course. It doesn't work because the deserialization fails. That's awesome. Hey, Desi used. Yeah, this is what we're trying to fix. That's funny. Although this is not the error I would have expected. So that's a bit surprising, actually. How disturbing is that audio? That's so funny. It says deserialization failed, so then why does it even overwrite any of the state? That's a bit surprising too. In any case, we'll just focus on getting this thing faster for now and not worry about it, and getting the actual save states themselves working without rewind. So I'll just disable this for now. But if nothing else, this is pretty cool. Was that not how you do this? Actually, let's do this just because I want to play with this. Do like 10 frame granularity. Although I wonder if it's capturing it that granularity then. I hope so. That seems faster at least, so that's a good sign. Drew, new question: if you wear those blue and red lenses while playing the emulator, do you see 3D? You should. Zokwar can confirm. It might be a little rough though, just due to the colors that are used here. I would like to have more options for that. I have a note of that somewhere, but haven't implemented anywhere or anything. Yeah, if I rewind. Interestingly enough, it looked like it worked. I don't think this worked, to be honest. I think it probably just crashed. And the software restarted anyway, is I'm guessing what happened. And I'm guessing that because we don't actually apply the deserialized state. We're still working on that. Anyway. This is pretty cool to see this almost kind of working almost. Anyway, so what I want to do next then is actually work on our deserialization and getting. In fact, I think we're already deserializing the version state structure, and I think we need to actually apply it. I think that's what we're missing now. And there's some assembler from my executable packer. Do not ignore the man behind the red curtain or whatever it is. I haven't seen that movie in years. Oh, by the way, I totally beat Crunchy, but that's a different stream. Here. I think, did we already do, because we have the version state and then to this state. And maybe we already did that. I don't remember. Or if that even makes sense. Because I think state... Wait, isn't state just an alias for the... Yeah, for the latest version. Right. So it's all this stuff. It's all this get state stuff that we have in here. And we're going to dupe that for setting the state. So what I'm going to do here is a couple things. I'm going to do new view into file so I can bring this down off screen so I can see the state saving code, and we're just going to sit here and chug through this. Before I do that, I'm going to mute my system audio and put on some music because this is going to be really boring. And I am glad I saved this for the stream, let me tell you. Cone Sound just came out with or they're coming out with a new album, I think, but that's not what I'm going to listen to. I'm going to listen to this playlist. I'm a huge fan of this guy, by the way. This is Rashad EB. I'm sharing this playlist. He does metal covers of video game soundtracks and some original stuff too. And I'm just a huge fan of this. This is the perfect kind of music for this kind of work. So, finally, let's get started. Also, I was going to do one thing really quick here. Yeah, I have a couple Squash Me commits in here. And what I'm probably going to end up doing is rewriting the history on this branch before we merge to master. And in fact, yeah, I'll probably move a bunch of this around and squash the history. But not right now. I just wanted to look at, because I think there's some to-do stuff in here. But maybe it's not stuff I want to address right now. Yeah, I don't think it is. Because I kind of just want to, like I normally do with this kind of thing, just get it working, and then we'll do a cleanup pass after. What else is Git for, you know? Oh, wait a minute. Oh no, this is the error that we were getting. Yeah, but that doesn't matter. Oh, that is awesome, Drew, too. I had no idea. I gotta check that out, too. Yeah. Okay, nothing in here we need to worry about. Just start digging in. Okay. I think one of the main things here is I just have to make like all these properties in the core public. And I'm okay with doing that, like even internal state. Because like the reason you would make that stuff private is to kind of like hide it so you can't poke into there. But ideally everything in the core would be public so like a debugger can at least read all that state. And it might be that I want to do like getters and setters for some of this stuff when we want to ensure that something that's like applying this state as actually doing what it's supposed to do. But at the same time, I think for the sake of simplicity, I might want to avoid that when the setters are so simple and not actually used by the emulator itself. I'm not really sure where I land on that, on the philosophy behind that at this point with this project. But anyway, so we did the ROM and the work RAM, and we haven't really done anything else with this state yet. But next I see SRAM, so let's go with that. Yeah, so the bytes and the size. So what's nice here, actually, why are those separate in the serialized state? That seems a little odd, actually. Because we should just have the bytes, shouldn't we? Like it seems redundant to have the size on there too. By the way, I do not care, since this is not like on master or anything. I don't care about breaking the serialization format now. We could just delete all the old saves, and then people who have worked on this, like Ep.070, is just gonna have to deal with that, and I think that's fair. If they have like local save files on their system. Oh, this is why. Because I always allocate the max SRAM size, and then I think we increase the size on writes. Or do we? On reads or writes. Yeah, that's what we do here. Okay, and so I guess I was serializing this entire buffer and the size. That's fine. Then we can just read all that back in. That's not a problem. Yeah, there's a lot of this data hiding that I think I want to get rid of eventually. But not right now. So I think for the ROM, yeah, we have this from bytes function too, which just load uses. Honestly, though, yeah, I'm going to do the same thing. And then we're also going to have this kind of error handling here. So we want that to bubble up. I think that's okay. I spent a lot of time thinking about this last time, and I'm just going to go with the design that I ended up with here. And that's going to be fine. Hey, Dark Second. Yeah, Rashadi B has a ton of stuff. And unfortunately, not all of it's on Spotify. Like, he has a Crade's Lair remix that I really, really like. And I really wish that were on Spotify so I could put it on my list. Alas, it's not. But in particular, I really like his Chrono Trigger and Undertale remixes. And a smattering of other stuff, too. Anyway, this SRAM error, and so that means in here, we're going to want this. Interestingly enough, the workram doesn't have this. Probably, yeah, I'm just assuming the size is correct. That's fine. And how did I do this for the ROM? Yeah, we did this result and then we mapped these IO errors here. That's fine. I'm going to do the same thing for the SRAM. This here. We'll do the size here too. And I think I made that a... What did I make it in the actual structure here? It was version 1. usize. Since this is serialized, this should not be usize, by the way. I know why it did that, but this should not be usize in a structure that we actually serialize. This should be a set number of bits and should not depend on the architecture we're building for. So I'm going to fix that right now, too. Don't know what I was thinking there. Probably I wasn't. U32 is going to be fine. We know that that is sufficient. So then when we save this out, we'll do as this. Nicer too. Of course you were. I don't remember when or how I discovered him either, but big fan. Anyway, SRAM, I'm gonna do this. I'm gonna make the size of usize here, and we'll convert in the higher level code. This should be a result, shouldn't it be? Yeah. Like this. And then it's really this that we want to do. And we're going to do some map errors here. Bloop, bloop. And this is going to do... I mean, in this case... Actually, yeah, because this writes out the entire SRAM regardless of the actual size that's being used. I should actually change that. No wonder all my SRAMs are always 16 megs. Because this should only write out the amount of space that we actually used. That's great. There were two. Wait, Double Zero says bin code deserialize all U sizes as U64. I mean, that's great if that's what it's doing. But I don't want to take my chances. Just gonna do this as a to-do for now, I think. Oh, are you saying that, Move? Are you saying that for this thing here? That might be a good idea. Yeah, I'll do another pass where I clean up the signatures here later, I think. I would really like to do that, but right now I think I just want to get this working here. Even though it is dumb that we allocate twice here, but I think that's fine. Yeah, Moran, what's going on? Does kind of suck specifying this, though. I mean, really, that should be the bytes, shouldn't it? Just seems silly when we're doing... Yeah, maybe I actually want to change how I serialize this. I think I do. Because I want this to have this kind of signature. In any case, this is what's wrong here. And that should be fine. Oh, yeah, I did a vec here, didn't I? Actually, let's do this just to make it match the other one for now. Again, I'll do a pass where I clean this up later, but just don't care right now. Oh, FS Read. Yeah, I didn't know about that. Whoops. I've been doing this for a long time. My Rust is starting to feel really archaic, rusty, as it were. Even 2vec was new to me at one point. I know we have shadowing, but a lot of the time I don't like to do this. And this pointer stuff is a dumb optimization too. I don't think we need that. But anyway, at least this more or less matches what I had before. So in this case, apply, we just want to do this. Right, and I think this is not correct right now because I believe we do SRAM state here. But I think the way that I want to do this is like this. And then we'll change how we handle that. Get rid of this SRAM state thing. I think that's what we want to do. So now there's some things that are going to be wrong here. Yeah, because we did as slice 2vec into box slice on the SRAM bytes. That's not what we want here. This will give us the same behavior that we have currently. I'm really not sure I want to fix this now. But I probably should. You know what I could do too? I could construct a more proper slice here. That would help. And then I could do this. And that would kind of solve both problems. I think I might do that. The type of these on, because this is interconnect state, so these are just the boxes here, and then the actual type is like this wrapper type. For example, SRAM has the bytes in a size and a pointer to that and stuff, and it'll do all the masking and stuff when you try to actually access stuff from it. So it's kind of that wrapper, but it's really the bytes that we need to serialize. I don't mind doing this unsafely because we know everything's safe here. We know that we allocate the maximum number of bytes for the save RAM internally, and then the size will always be within that. So I don't really mind if we do that. But anyway, just talking out loud here. 420 Python, how's it going? Yeah, clone on that actual vec could work, or the box slice if we want to take that in. Yeah, I'll think about that in a second. Thanks for bringing friends, Michael C. That's funny. Like, it's kind of cool that you can get these iterators over these chunks. I mean, we could do the first one for this. But like slice, I just want the first part. Happy birthday, Jamie McLean. Why not? T is size of length 1. That's actually kind of fun that it has these. These from mute and from ref. I mean, I guess the safe way to do this. Oh, what am I thinking? Oh my god, this is so dumb. There's totally a syntax for this. It's this, isn't it? Self.size. Stupid. That's exactly what I wanted to do. And then this kind of solves all the problems that I was thinking. Except I think we're still copying. But anyway. SRAM, yeah. So in here, what's that here? Where was that? 342 in this one? Guessing that's here. Yeah, because we don't have SRAM here. That had to do it. Right, and then this can fail. So we want to map the error too. And this will be SRAM error. Yeah, good. This more or less makes sense. Oh yeah, that is dumb that I don't just clone when serializing. That's what you mean. Okay, that's awesome. Thanks. I think. Oh, it's because I'm hiding the data. That's why I was doing that. So I mean, if I make like bytes and stuff public on those structures, then I can just clone it. That's why I didn't clone that. I'm actually going to leave it like this for that reason. As I said before, I'm still not sure if that data hiding is something that I still want. But that's at least why I did that, I think. Sorry, I'm being confusing. I didn't quite know what you meant. Anyway, making a little bit of progress here. I'm guessing this. I know that this is going to be super tedious, so it's going to take us a while. It doesn't really matter if we go a little slow. I'm so torn about this. I feel like I just keep going back and forth on whether or not I want to like fix this stuff and remove this data hiding stuff. Feeling scatterbrained today. By the way, stuff like pointing out those convenience functions for a lot of this stuff, pull requests would be a really good way to get those in, because I'm probably going to forget. But I would ask maybe, just because of all the moving parts, that we wait with some of those until we're getting ready to merge this. Or maybe not. I'm not sure. Just don't do it right now. No, this field is not public in this serialization crate. This is not a public bytes field. It's public on the serialization structure, but not on the structure that we're going to apply it to, which is why I'm doing this, like creating new ones, like from bytes and stuff. But I'm not sure it matters, because I wanted it private so that like internally the emulator wouldn't touch that stuff how it wasn't supposed to. Yeah, thanks, Repnob. I appreciate that. Yeah, we have the VB interconnect ROM dot as slice there. The VB interconnect ROM, or as slice, is a function that we've implemented here. Again, remember ROM is this structure. So we don't have access to the bytes. We have access to like as slice and stuff, so we can serialize those. If it were vb.interconnect.rom.bytes, that's what we would use. Then we could clone that. And I might be okay with doing that, but I'm not sure. Because I get the feeling now looking at this, and as you're saying this too, that having all these extra functions here, it might just be more effort than it's worth. Because even just having these read byte and write byte functions here kind of gives us the interface that we want from inside the emulator. And even if we expose the bytes as like a public field, it's still pretty obvious that that's not what you should use when looking at the structure most of the time, even though that might be the appropriate field to use when like doing serialization. I'm not sure. Yeah, no worries, Open Up. If it sounds like I'm getting frustrated, it's not at you. It's just that I'm really torn about how to do this. The beach background. Yeah, I need to do fancy backgrounds with my new green screen. Definitely a missed opportunity there currently. I might just make an executive decision here and just get rid of all this data hiding. I kind of think I wanted to make it work with this philosophy still, and then revisit that later. But now's as good a time as I need to do this. So I just want to look at like the VIP, for example. Like the only thing that this really even hides right now is like the gamma table, which we're not going to serialize anyway, and then the VRAM. And V810 is going to be similar. Yeah, it just has these and then these. So it does make sense while we're using this like pointer optimization, where we get the pointer to the box and then we use that to index this a little faster. But I don't think we need that anyway. Yeah, I'm just gonna blast through this, and we're just gonna make this stuff public and just say screw the data hiding, because I think it's just having more code, and the more I think about it, the less I like it. And stuff like this, I don't love this. Because we can still do like this, for example. We need a slice for that. And then this still works as we expect. Like, I don't mind having these conveniency functions here. Like, from bytes still makes sense, but like this just seems a bit stupid now. So, yeah, I'm going to commit to this. And then get rid of this. Going to get rid of this. We're going to get rid of all this bytes pointer crap. And we're just going to make this public. That's fine. I'll just change this. It's not like this is difficult. 32 is offset. Yeah, so we'll do, it's literally this. Because we're indexing the array instead of offsetting the pointer. Same thing. I actually don't know why that didn't like that there. Oh yeah, because we're doing unsafe and we're still doing this syntax here. So that one should be okay. Oh yeah, we don't have bytes pointer anymore. It's just bytes. Fine. And then do this here too. And then same stuff here. In fact, I'll do this too. Why did I implement clone for this? What is that for? I don't know. I'm not going to look into that now. that really doesn't matter. Yeah, let's do this. Yeah, this could be a derived clone now. You're absolutely right. It couldn't before because of the other stuff, but now it can. And I'd rather have it be that then. Nice call. Just gonna make sure this builds. It doesn't because now this as slice thing is wrong. Because now we can do this. I actually might still do as a slice though. And that I think makes sense. To still have the clone here because we're only going to take that many bytes. But for the other ones, we'll just do clone. Okay, I'm somewhat happy with that. Let's give ROM the same treatment. Because I think the only stuff that was using this as slice stuff was like the debugger, and that's on some other branch, so I can fix later anyway. Yeah, really not worried about that. Because I wanted to remove this pointer optimization anyway once I started profiling after all this was implemented, so I'm fairly happy with doing this. We're gonna have to do this a couple more times. Because I wanted to remove those optimizations and then get some actual profiling data and then maybe reintroduce them if it made sense. But for now, we'll just say screw that. I doubt that bounds checks on vectors is going to be where our performance problems lie. That seems like a very predictable kind of branch. Especially since we know that's predictable since we were doing the pointer dereferencing anyway. So that should be fine. Really? It's len, isn't it? And then, yeah, clone here is the derived clone now. Yeah, when we actually start profiling this, I want to dig really deep with that kind of stuff. But until then, let's just make this the way we want it. So now if I build this, this will fail because of that. And then it should just be bytes clone. And that was for ROM that I just did that for. I hope I did that on the right monitor, or the right area of my monitor. Probably don't need to build for release if I'm just checking if it builds. But whatever. Yeah, this gets the pointer to these bytes when giving it to the front end. That's what that's doing. So that's actually up here in boy Libretro. In particular, that's in lib and 424. Yeah, I'm thinking the same thing, RepNop. Because I just don't think these are going to be our hot paths. Yeah, we can do cargo check, can't we? Forgot about that. This probably takes a minute the first time because it probably like checks with like a debug configuration, which I haven't done for any of this. The emulator is just so slow in debug that I just never use that anyway. So that's why this is taking a minute. Hey, Matt RVA. By the way, I never asked if RVA is the same RVA that's in the Windows PE format. So this can be that. Really? Oh, yeah. We're casting it to a void pointer. You know what we can do is do this cast out here, because they're all the same types. And then we can get type checking here. No, did that not work? Really? Oh, because null mute, maybe? No, that should be typed. Okay. I give up. Oh, gotcha, Matt, are you? That's still cool. Yeah, while I'm at it, I'm going to hit the WRAM and then the VRAM for the VIP with the same treatment. Does this have clone too? No, it doesn't. So what was I doing cloning the other stuff? I don't understand what that was for. Yeah, the more I think about it, the more I like not having data hiding on all this stuff. Like, as far as I'm concerned, the emulator core, everything can just be public. And then we just trust that things that are using it aren't abusing that. Because I just think it ends up being less code overall, and these interfaces are not confusing enough that like someone using the core and like integrating it into another project, whatever, be confused about which part of the interface to use. It should be really obvious when reading this code, even just at a glance. And the advantage of having just all this state public is that any kind of tool that we would want to build, and serialization is a good example of this already, that wants to inspect the state can just inspect all of it. And that shouldn't be a problem. Especially as this is just a crate that covers core emulation. I feel like that's a consistent philosophy. So I'm okay with that. Let's do this. Cannot type today. Totally is. Did I not? What? Oh yeah, same thing in here. And it's totally like we're potentially violating a lot of Rust rules by some of the stuff that we're doing here, like taking pointers to these. But again, I feel like we're pretty safe. Like the emulator itself is not going to replace these collections. And I feel like it's okay to rely on that in the Libretro layer. I really don't mind being a little unsafe. Especially because the way I see the Libretro like layer here is I don't mind being like really pragmatic here. It's not a terribly complicated API anyway. So it's pretty obvious when you mess something up here. Maybe it reduces some of that, oh, it's Rust, so it'll never crash feeling, but I think that's fine. The VRAM on the VIP now is what we need to do this to. Also, this is cool because eventually I think maybe I'm already doing that for some of this stuff. Yeah, a lot of this like waveform data on the VSU is already public anyway. Why not, you know? And then it still makes sense for a lot of this stuff, like a lot of this has functions for reading and writing register values, and that I still want. Because in some cases, like it's trivial like this, in other cases we only take like certain bits. And then going through these interfaces, I think is the best way to do that because you keep that behavior local to this code. But that's different than just hiding the implementation specific stuff. Anyway, enough chit chat about that. This is good. The other reason I'm using box slices here is because I don't want a resizable type. Again, that makes our pointers such that they're a little more reliable anyway. But that's not why I want to do it. I just want to have it semantically be known that we're not supposed to resize this. We are going to want to be careful with some of this stuff now I think about it, though. Like when I think this makes sense though, because like when applying the state, we don't want to replace collections. We want to like overwrite them. And that way stuff like this will still work. And that's probably the most efficient way we can do that anyway. Just because we're not doing any allocations or anything. We're just copying the data from the deserialized data. Yeah, I think we're good. So we don't need VRAM pointer or VRAM slice here. And this probably starts causing a lot of problems. Oh, this is nice that I just have everything in these functions. Maybe I don't want that then. These are internal here. Oh, I will want them for like these, but for the reading, writing bytes, maybe not. It's not like we really need this to be a consistent interface. I'll leave that for now, because that doesn't really matter. Where was this? I keep hitting it and then... Or do I? Here. Okay. I think too, I want this emulator to be an example of not necessarily the best idiomatic Rust ever, but I want it to be a good example of a real emulator implemented in Rust. And if that means that we do some things that aren't quite safe, or put another way, if we prioritize pragmatism over form in some cases and over safety, I think we're okay doing that. Congrats on the new job, by the way, Ripnup. this should not build because of this. First of all, this one. And also because of this. Yeah. So now that we've basically covered that, I want to look at the code that puts us back. Yeah, so in this case, we actually replace these, which I don't want to do now. And here's the irony. Oh, wow, that is awesome, Ripnop. That's insane. The irony is this error handling stuff that I was looking at earlier. Now I actually don't want to do that. Because now I just want to copy the bytes, which will make all this simpler anyway. So I'm fairly happy with this choice. Wait a minute. You know, I'm not so sure about this when deserializing. So here's what I'm thinking about and why this is a problem. When we deserialize, we might be, like when we're applying a new state, we might be applying like an old save state that had a different ROM loaded, for example, or a different size SRAM because of what was used. And so we don't necessarily want to just copy the data. Well, that's cool, Ripnop. We do want this actually public, though, outside the crate, but that is good to know. Because like the serialization crate is a separate crate than the core emulation crate, which I want to keep that way. But the issue here is that we might actually be getting like a save state that was older that might have different size buffers than we have in our current state. So we actually do want to replace these structures when we deserialize. And that would mean that stuff like these pointers that we're handing out here would not necessarily persist. I'm hoping that the front end would be smart enough to know that. I don't necessarily trust that it would be, though. I don't know how often it's expected that this might get called. My gut feeling is to not worry about it, though. But we don't know. Because I think here... Yeah, notice here, it actually does read out these pointers and their lengths. And I didn't see it doing that again. Maybe that means something. What I don't like about this is that I don't want to change the implementation details of the core just to suit this kind of front end. So for example, I don't want to necessarily always allocate the biggest buffers here just so that we always have that memory on hand and we're not changing the pointer. Although maybe that's a good idea for speed anyway, because there's no reason why we should reallocate these if we don't have to. So maybe that's okay if we do that, actually. For stuff like the VRAM, that doesn't matter because it's always going to be the same. I think SRAM's the only one. Well, SRAM and ROM are the only ones that are actually dynamic. And we could always just allocate the largest sizes for those. It's only 16 megs in either case. And I think in the SRAM we already do that. That's why we have this separate size. But on the serialized one, of course, that's baked into the collection. But then, like, if we were applying this, we would want to clear the rest of that memory as well to uninitialize values when loading the other state. I mean, we wouldn't have to. Because the ROM, if it hasn't touched that before, should assume that that's uninitialized. So I think that would be safe. Yeah, I think the ROM itself. Yeah, I'm actually leaning towards that. Leaning towards always having the ROM buffer internally be the largest size that we support, and then just overriding the data and perhaps the size. Because I think like mask adder here, yeah. So we know when we're loading it that it's a power of 2 and it's within bounds. So that here we can mask it like that, and then we mask that off for all of our reads. And of course, there's no writes for ROM. So in this case, we would just have a separate size like we do with the SRAM. Maybe that's okay. I think it is. We're doing this. And in fact, that makes this wrong from bytes for SRAM. Because this needs to always be able to contain the max SRAM size. So this code's actually wrong currently. I mean, it would always work the way that we've serialized this before, because we always have serialized the entire thing before, but we've already fixed that, so this is actually wrong. Yeah, let's do this. Yeah, so instead of doing the copy here then, in fact, is from bytes actually used anywhere than this anyway? I don't think so. As far as I know, any front end that we have, like we call load and stuff on this and on SRAM. We just build new ones. That's fine. Save out the SRAM. We might want to get rid of these unwraps here at some point. I get really lazy with that at top level code like this. And especially with this driver too, or not driver, front end. Yeah, we're going to do this. We'll get rid of this from bytes thing in the first place. We'll do this. The vec we're not going to copy. Like this. Oops. And I still like having this kind of more semantic result type here, because if it's an IO error, we can report that more specifically. And then like in this case, it's an invalid size, which is not an IO error. So we don't want to wrap that up in an IO error like we did before. This is kind of better duct tape. Yeah, we want to copy the data, though. That would help. Hey, you can do this now, can't you? That's rad. That's a pattern that I have like never used since I've been using Rust, but I actually really like that. What would be a good way to copy into this? What's the best way to copy bytes? Really? Clone from slice? But we want copy from slice in this case. We know it's U8s. So then we should be able to do bytes dot copy from slice back. That I like. Hey, like some text. Yeah, I think this is what we want, because we want to copy the elements from the buffer that we read from the file into the full size buffer that we have here. So that's good. And then now our deserialization code here. What was that? The ROM I just did that to? Yeah. Then in this case, this is kind of cool because we're not going to have appliers anymore, which I didn't want in the first place. I just had because let's get rid of that. The SRAM one is still going to give us errors until we fix that, but I don't care right now. We're basically just going to copy the bytes and then write the size. So dot bytes dot copy from slice, and then that'll be state connect ROM like that, and then size is Rebnop, do you ever think about making a Discord channel or something for your stream? I have thought about that. In fact, I might have squatted it already. Well, you can't really do that on Discord because I guess you get different IDs if you have multiple rooms of the same name. But I actually have that. It's just I'm never on Discord these days. Not even in the Rustral Boy one, which is something I might start trying to fix soon. But I've thought a little bit about it. But I don't think it's something that I'm actively considering right now. In this case, the work RAM, this is actually going to be perfect for this. Yeah, I like this. It's just copying the bytes now. That makes me happy. And then, of course, this is returning a result anymore. And we need to do this thing to the SRAM too. Is that what it was? Copy from slice? Yeah, I have it down there. Yeah, I like this. I like how this code's starting to look. You know, while I'm in here, I might as well do that suggestion you had earlier, RepNob. It's funny how I like instantly have that reaction sometimes about like I don't want to think about that small cosmetic change because I'm doing something else, but then I always end up doing it anyway. So I guess this would be read. We would have that, wouldn't we? And we no longer need. Oh, I think for saving it, we still did file create. Is there fs write then as well? Yep. That's cool. Then we don't need any of this except for the error. In which case we can do error that this is read, and then this becomes write. Did I do right here? No, I need this here as well. And I'm guessing this is gonna do that. Look at this. Oh no, I wrote that earlier, didn't I? I totally did, I bet. And then we'll do, actually just do this then. Yeah, actually let's bring these in. Like this, just to make this a little more clear. That's nice. So we'll do the same thing to the ROM. Actually, this doesn't even have write, does it? Just use read. And then, yeah, this doesn't need to be mutable anymore. Fantastic. That I'm really happy about. It's nice when things get cosmetically nicer as well as work better. I think we've removed more code than we've written today, which is really good. And then here, we want to copy this stuff and set the size just like we did with the ROM. Again, we're assuming that the deserialized save state is okay here. It may not be with regards to some of these sizes, but at least these copies will panic if they have to. So at least we're safe from like some kind of weird exploit or something. Even though we may not get entirely correct behavior from the emulator in that case. Don't think that that's something we need to really prioritize. And I think, yeah, here's the irony. We don't need any of these anymore. Let's check this. And then this is in Libretro. I do also want to run the CLI after this. We'll worry about that later. 104 here. From bytes. Oh, we don't have from bytes anymore, do we? Crap. We actually still want that, don't we? I think so, because I want to have like the bounce checks still happen there. That's fine. We can reintroduce those. You know, actually, let's think more about this. Yeah, actually construct a new system in this case. Yeah, no, in this case, from bytes is correct. Instead of creating a new emulator and then overriding the ROM, which we could also do, but I'd rather do it this way. I like this interface in this case. So we're doing this. And this, I think, yeah, data ref. Is that the... Yeah, we'll stick with this. That. I hate when this happens. YOLO. Okay, I think I like that. While I'm at it, I'm going to change that in. I think it's only SRAM that also did this. If we even need that, because I think we removed that function there. Yeah, we're good here. And I don't think the front end actually used that. Maybe it did. Maybe that's what this is. Oh yeah, we need to change the name here. From slice. And it's had some other errors here too. which is 239. Or was it? 293. Thanks, reading. Oh yeah, apply doesn't return a result now. So we don't really have to error check this. Right, because then we'll get errors if the deserialization failed, but not if applying it failed. Because that's not going to fail with what we've done here. With what we've done here. Words. I like this. Oh, it's been an hour and a half already. I'm probably going to call it quits here for today. Didn't make terribly much progress, but at the same time, we cleaned up a lot of stuff, so I'm pretty happy with that. And then next week, we'll chug through some more of this, I think. Seems like a good idea. Ruh-roh. Oh, really? Okay, we're going to need to fix this. Hey, Molliff. Yeah, a bit unfortunate timing there. Did I not read? Yeah, okay. Copy from slice panics if the slices have different lengths. Whoops. That's okay, though. This is easy to fix. So I think we did copy from slice here, because we can do this. Like that. So this is not bad. I think it was just the SRAM and the ROM that did this. And then in here, we'll do the same pattern. Plenty of places that Rust will catch us if we're wrong on any of this. So we're good with that. Oh, what? Something's not working properly. This seems to happen when we just start executing basically nothing out of memory, and then the CPU starts reading opcodes from not code or beyond certain memory regions, and we seem to get issues like this. But where did we go wrong is the question. This is a bit unfortunate. I'm gonna want to fix this today. I'm guessing something isn't setting the size correctly here. But I don't know what that would be. Yeah, that's exactly it, Molliff. And I prefer that. Let's do this at least. That's because of this. See if we can at least get that. Okay. Yeah, read half word in step here. Doesn't really help us, does it? I don't think we'll get a better backtrace than this anyway, because we see that it happens in interconnect, and that just doesn't really tell us anything. But I'm guessing now that we've exposed this stuff, we just bootstrap something wrong. Oh, you know what? I can almost guarantee you it's this. And then SRAM should be doing that when it masks its addresses as well. This seems wrong, doesn't it? Because first we mask by the SRAM size, and then this is while the address is not less than size. We're going to multiply the size by 2. This should be while. So you just bump up to multiply the size by 2 by the time it gets here. And we know that the way that this is masked... Yeah, this is correct. That's funny. Anyway, this should fix the problem. I'm guessing what happened here is that we had a ROM. In fact, if you look at the size of bound high, we'll probably see that it's less than 16 megs. I'm just going to double check that in Windows here. Yeah, bound high is a 2 meg ROM, not a 16 meg ROM. I don't think there are any 16 meg ROMs that were actually released on the system. So then I think what happens is that because the V810 starts executing out of the top of the address space, and the ROM only took out a bit of that, since we were masking based on the size of that buffer rather than the size that we have on the ROM struct here. We were reading out of some uninitialized memory instead of what we should have been reading, which would have been a mirror of the actual data if this were being masked properly. I think. So if this works, that's definitely what it is, and then that should be the only place we need to fix that problem, because again, the SRAM should have been masking properly, except it wasn't expanding its size automatically properly, but we should have fixed that now. There we go. Nice. Okay. Lots of small things here. I had 2 things to say about this, and I don't remember what the other thing was. Oh, yeah. Okay. Anyway, I think this was productive. I'm going to head out. So thanks guys for hanging out, and I'll see you next time. Did I forget anything? No. All right. See you guys.